Hello everybody, this is Coach Knight, and I'm going to show you a few examples of how to deal with geometric sequences here. First off, what we need to know is what a geometric sequence is, and a geometric sequence is just a sequence of numbers where you multiply by some number to get the next number. So like our first one here is 1, 5, 25, 125, and that is multiplying by 5 every time to get the next number. The geometric sequence's equation, or the rule, is right here, and that you read that a sub n equals a sub 1 times r to the n minus 1 power. So basically this will give you any term in the sequence. So if we wanted to write an equation for this first one here, my a1 is the first term, which would be 1, and my r is the common ratio, and you can get the common ratio by dividing any number by the number in front of it. So you could say 125 divided by 25, or you could say 25 divided by 5, or you could say 5 divided by 1, and they will all tell you that r is 5. And so the equation, or the rule for this geometric sequence, would be a sub n equals 1 times 5 to the n minus 1. That would be your rule. The second one here, you have 9, 3, 1, 1/3, and 1/9. So doing the same process, a1 is that first term, is 9. R, again, you can use any of these numbers. I'm going to use 1 and 3 here because that's pretty easy to divide. R is 1 divided by 3 is 1/3. And so its equation would be a sub n equals 9 times 1/3 to the n minus 1 power. So that's basically what a geometric sequence is. I have some examples here. I'm going to work one and leave one for you to try by yourself. I will write the answer down for them. The first two are very simple. They're very similar to the ones we just did. Here it gives you a sequence. It is geometric. And again, you just need two things. You need to know what a1 is, and you have to know what r is. And if you know those two things, you write your equation and you got it licked. Okay, the equation is a sub n equals a1 times r to the n minus 1. Again, that's the rule for any geometric sequence. So for number 1 here, our a sub 1 was 6. That's the first term. R would be 2 divided by 6, which again is 1/3. I didn't have to use those two numbers. I could have done 2/3 divided by 2, or I could have done 2/9 divided by 2/3. Either way, you get 1/3. Okay, they'll all have the same common ratio. And then after you got that, it's just plugging in. So a sub n equals 6 times 1/3 to the n minus 1 power. The question also says, then find a sub 10. Well, to do that, all you do is plug in. So a sub 10 means they want the 10th term of the sequence. Now, we could, if we wanted to, we could go through and just keep going until we got the 10th term. This is the first term, second term, third term, fourth term. We could just keep dividing or multiplying by 1/3 until we got to the 10th term. However, it's much quicker just to plug it in. So we're going to plug in our equation. 6 times 1/3 to the n is 10 minus 1 power, which is 9. And if you put that in your calculators, you will see that is, calculating it here, 2 over 6,561. That would be a sub 10. There's a sub n. Very simple. If you want to try number 2 on your own, your equation should be 10 times negative 2 to the n minus 1 power. And when you plug in 10th, a sub 10, you get negative 5,120. And that makes sense because 10 is an even term. And if you notice in our equation, the second term was negative, the fourth term was negative. That means the sixth term will be negative, the eighth term will be negative. So the 10th term should also be negative. So if you want to try those are the answers you should get. 3 and 4 are different kind of examples. They give you 2 separate terms here, and you have to do systems of equations to work these out. So when they do this, it's a little more complicated. It's actually a lot more complicated. It'll be a lot more work to show. However, it's not that bad. So here, basically, again, we're using our geometric sequence rule, a sub 1 times n to the r minus 1 power. And so basically what they've given us here is what a sub n is. Okay, so for this one, a sub n would be n is 3 and a sub n is 20. So 20 equals a1, we don't know, r we don't know, but we know a sub n and we know n, 3 minus 1. And then we do that same thing for a sub 6 and negative 160. So those are also a term. So negative 160 equals a sub 1 times r to the 6 minus 1 power. And basically we simplify these. 20 equals a sub 1 times r squared. Negative 160 equals a sub 1 times r to the 5th. And here is where we do a little bit. This is 2 equations. So we have to do substitution, have to do a system of equations. And to do that, we are going to solve one of these for a1. It doesn't matter which one. I find that solving the one with the smaller exponent is usually easier. So I'm going to divide by r squared and divide by r squared there. And so here, a1 equals 20 over r squared. And I'm going to take that and substitute that a1 for the a1 in the other equation. So this will be negative 160 equals 20 divided by r squared times r to the 5th, which is just negative 160 equals 20 r to the 5th over r squared. And when you simplify those, you get negative 160 equals 20 r to the 3rd. And we divide by 20. Divide by 20. You get, that's negative 8 equals r to the 3rd. And when you take the cubed root of that, you get negative 2 is r. And now remember, we only need a1 and r, and we have our equation. So we got r, we're halfway done. We're going to take this r and go back and substitute it in for r in the other problem. So a1 equals 20 divided by negative 2 squared. a1, if you put that in your calculator, that's 20 divided by 4 is 5. And so now you have everything you need to write the equation. A sub n equals a sub 1 is 5 times negative 2 to the n minus 1 power. Like I said, there's a lot of steps, but it's not that bad. You can do it. You just got to remember how to do substitution to work out the system of equations. Number 4 here, if you want to try it, I will write the answer down for you. I have to find the answer first. So I guess we'll work this one out. That would be 12 equals a sub 1 times r to the 2 minus 1 power. And then this one will be 3 equals a sub 1 times r to the 4 minus 1 power. Simplify those. 12 equals a1 times r. 3 equals a1 times r to the third. Again, we're going to solve the one that's the smaller exponent first, so we're going to divide by r. Those will cancel, and a1 is 12 over r. And we're going to take that and substitute a1 in for the other equation. So 3 equals 12 over r times r to the third. Again, that will reduce to 12r squared. R to the third over r would be r squared, and we divide by 12. We get 1/4 equals r squared. To get rid of a square, you take the square root. And final answer, 1/2 is my r. We take that and plug it back in to find a1. So a1 will be 12 divided by 1/2. a1 is 24. And so now we have a1, we have r. It's just a matter of writing out the equation. 24 times 1/2 to the n minus 1 power. All right, last example I'm going to do with you. It says find the sum of the following. So if you don't know what this kind of E-looking thing represents, or you've forgotten, that stands for sum. It's a summation. And basically what they want you to do is plug in k equals 1 and solve that. And then plug in k equals 2 and solve that and add those together. Then plug in k equals 3 and solve that and add that one to it, and just keep going until you get to 10. So basically if we plugged in 1 here, we would get 4. Plus, if we plugged in 2, we would have 4 times 3 to the 1 power would be 12. Plus, if we plugged in 3, that'd be 3 minus 1 would be 3 squared is 9 times 4 is 36. And as you can see the pattern, they keep multiplying by 3 every time, okay? And you would just keep going until you had all 10 terms. Well, with geometric series, this is a series. A series is when you add them up. A sequence is just when they are just numbers like this written down in a row, okay? A series is doing the same thing, but you're adding them in between. So for number 5, the sum of a geometric series is a1 times 1 minus r to the n divided by 1 minus r. So basically, we know everything we need to know from our problem, okay? Our first term, s sub n in our problem, how far is it from 1 to 10? And that answer to that is 10. There would be 10 numbers that we'd be adding here. So we're finding s sub 10 equals the first term again. We got 4 times 1 minus our r. R is always what's in the parentheses there. It's 3, so minus r, or 1 minus 3 to the, again, n power. So in this case, n is 10 divided by 1 minus 3. And if you put all of that in your calculator, you should get 118,000 196. Again, we have number 6 here. I'm going to leave it for you to try, but just so you know, you should get S sub 6 equals 9,765. And like I said, I'll leave that one there for you to try to do on your own. Hope this little tutorial helped. Keep battling, keep fighting. Don't let the math problems whip you. All right. Until next time, I'll talk to you mathletes later. Have a great day.